All right, in this first section here of Chapter 8, we are going to look at solving systems of linear equations. So this is something that we did in both Algebra 1 and Algebra 2. So hopefully this is a fairly straightforward review. So a system of equations, or systems of equations are sets of equations with the same variables. In this first section, we are just going to look at equations in two variables. Okay, so the solution for a system of linear equations is in two variables is written as an ordered pair. Now, to check whether each ordered pair is a solution of a system of equations, okay, so here we have this system. We want to check each ordered pair. I just want to plug each ordered pair into each equation. So I'm going to plug 3 in for x and 1 in for y into each of these. So I will have 2 times 3 minus 1 equals 5, and I'm just seeing if this is true, right? So we end up with 6 minus 1 is 5. That works, right? 5 equals 5. Then I want to do that for the other equation. So if I plug 3 in for x and 1 in for y, does that equal 5? So 3 plus 2 times 1 is 5. 5 equals 5. So since this coordinate point is on both of these lines, right? When I plug them in, it works. That means that that point is a solution to the system of equations. Okay, so why don't you guys take a second here and try this one. All right, so if I plug 4 in for x and 3 in for y, we will have 2 times 4 minus 3. So that's 8 minus 3 is 5. Yep, that works. Then if I plug that into my second equation, I will have 4 plus 2 times 3. So 4 plus 6 is 10. That definitely does not equal 5. So that means this point is not a solution. Okay, this point is on the first line, but not on the second line. Okay, so this is not a solution to the system of equations. Okay, now, when we're talking about a solution, what we're actually saying is where those lines intersect. Okay, so our first method to solve a system of equations is going to be by graphing. Right, so I just want to graph both of these lines and see where they intersect. Right, that's if we think back to the first example, okay, what this means is that the point 3,1 is where these two lines intersect. Okay, that is the solution. So to find a solution, let's graph these lines. So remember, if I'm thinking in terms of y equals mx plus b, this is my y-intercept, and this is my slope. So I'm going to start at negative 4, and then this first line, I'm going to go up 2. So this will be my first line. Right? It's going to do something like this. Right? Just a little bit off. There we go. That's a little bit better. Then my second line, it's actually not in slope-intercept form. Okay? So usually, the easiest way to graph a line is to put it in slope-intercept form. So let's do that. Let's solve for y. So I'll subtract the 2x over. So I'll have 3y equals negative 2x plus 12. And divide everything by 3. And we'll end up with y equals negative 2/3 x. Then 12 divided by 3 is 4. Okay, so to graph this line, then, I'm going to start at positive 4. And then I'm going to go down 2 over 3. Down 2, right, 3. So this is where this line's going to end up. So the solution is this point right here where the two lines intersect. So we always want to write our final answer as a coordinate point or as an ordered pair. So the answer is the point 2, 3. Okay, that's the solution to this system of equations. All right. Now, so the first is the equal values method, and this is a specific subset or sub way of finding or of using substitution. So if I've got two equations that are already solved for the same variable, y equals 3 minus x, y equals 3x plus 11, what I can do is just set 3 minus x equal to 3x plus 11. Okay, what I'm trying to do is find where these two lines are equal, right? The place where they intersect. So I can just say 3 minus x equals 3x plus 11 and solve this. So I can add x over to the right, subtract 11 over. So I'll get negative 8 equals 4x, divide by 4, and I'll get that x is negative 2. So now, once I get this, I need to plug this back in. It does not matter where I plug it in. I can plug it into either of my equations to solve for y. So I'll plug it into the first one. Say y equals 3 minus negative 2. So we end up with y equals 5, right? 3 plus 2. So now, remember, write your final answer as a coordinate point, or an ordered pair. So my answer is the coordinate point, negative 2, 5. And if I were to graph these lines, that is the point where those two lines would meet or would intersect on the graph. Right? So now, the more general substitution method, okay? And we would use this method whenever I see one of my equations solved for one of the variables. Okay, so the idea here is I can take what x is equal to. So x is equal to y minus 1. And I can plug that in place of x in the other equation. Okay, so I'm just going to say 5 times y minus 1 plus 2y equals 16. And now I have an equation in one variable that I can solve. So I would distribute the 5 through, combine my like terms on the left side. So that'll be 7y minus 5. Add the 5 over, divide by 7, and we get that y is equal to 3. All right, so now I can take this answer of y equals 3 and plug it into either of my original equations for y. The first one looks a little bit easier, especially since x is already by itself. So I'm going to plug it in there. So we'll have x equals 3 minus 1. So we get x equals 2. So that means my final answer is the coordinate point 2, 3. Right? Remember, x always goes first, then y. So again, if I were to graph these two lines, that's where they would intersect on the graph, at the point 2, 3. All right? So you guys take a minute and try this one. All right, so on this one, we already have y solved for in the second equation. So I'm going to take this 2x plus 9 and plug it in for y in the first equation. So I'm going to end up with 2x minus 5 times 2x plus 9 equals 3. So I'm going to distribute this negative 5 through the parentheses. So we'll get 2x minus 10x minus 45. So combine my like terms, and that'll be negative 8x. Add the 45 over. And divide by 8, or divide by negative 8. And that gets me negative 6. So now, take this, plug it into either of the original equations. I'll choose the second one since y is already solved for. So 2 times negative 6 plus 9. That'll get me negative 12 plus 9 is negative 3. So remember, again, always write your final answer as a coordinate point. So negative 6, negative 3 is my final answer. And again, if I were to graph these two lines, that's where they would intersect on the graph. All right? So the last method, right, is the elimination method. This method is what we use when both of our equations are in standard form. Remember, standard form is ax plus by equals c. Right? So I've got my x's and y's on one side of the equation and the constant on the other. So the idea here is we want to eliminate one of the variables. Right? So I'm going to move this over here a little bit. What I want to do is multiply one or potentially both of the equations by a constant so that one of the variables will cancel out when I add the equations together. Okay, now what that looks like is this. Now I can choose either variable to eliminate. Sometimes it'll make more sense to eliminate one or the other. In this case, it doesn't really matter. I've got x and 3x, 3y and negative y. Neither of those would cancel out when I add them as is, so I'm going to have to multiply one of the equations by a constant. I'll choose the y's to eliminate. So I have to think about what number I need to add, or I'm sorry, what number I need to multiply one of the equations by so that when I add them together, they'll cancel out. If I think about this, if I multiply this equation, right, everything in this equation by 3, the y's will cancel out. Right? So if I multiply this equation by 3, what happens is I will have 9x minus 3y equals 3. Okay, I'm multiplying everything, okay, because what I do to one side of the equation, I have to do to the other. So I'm multiplying everything in this equation by 3. Now, I'm not going to change my first equation. That's going to stay as x plus 3y equals 7. All right, so now, if I look and I add these two equations together, x plus 9x would be 10x, 3y minus 3y, or 3y plus negative 3y cancels out. Okay, I'm not left with anything there. And then 7 plus 3 is 10. Now, just divide both sides by 10, and I get x equals 1. Right? So now I just need to take this and plug it back into one of my equations to solve for y. So it doesn't matter. I'll choose the first one. So plug 1 in for x. So 1 plus 3y equals 7. Subtract the 1 over. 3y equals 6. And divide by 3. You get y equals 2. So my answer is the coordinate point 1, 2. Right. Let's take a look at another one here. So in this next example, again, doesn't matter which variable I choose to eliminate. I'll use the x's this time. So move this out a little bit. If I want these to cancel out, I'm going to need to multiply this top equation by negative 2 one way that we can use is if I look at the coefficients, I'm going to multiply this top equation by 2, the bottom equation by 1. Okay, I can just take the coefficients and multiply the opposite equation by the opposite coefficient. And then I would just need to make sure that one of the signs is different, right? So here, since both of my x's were already positive, I would just need to make one of those coefficients negative. So I'm actually multiplying this whole bottom equation by 1 as well. Right? Obviously, that's not going to change the bottom equation. Right? But the easiest way to think about this is just take whatever the coefficient is here, multiply the other equation by that, then take the coefficient here, and multiply the other equation by that. All right, so what's going to happen? I'll get negative 2x, negative 2y equals negative 6. And then down here, this equation stays the same, so I will have 2x plus 2y equals 9. So now, let's add these equations together. So negative 2x plus 2x is nothing, right? Those cancel. Negative 2y plus 2y is nothing. Those cancel out as well. Equals 3. So I end up with 0 equals 3. That is not a true statement, okay? 0 does not equal 3. Whenever we get something like this, okay, where both variables cancel out and we get an untrue statement or a false statement, this is where we have no solutions. So if I were to graph these two lines, they would end up being parallel. They would not intersect. All right? Let's take a look at one more example here. Now on this one, my equations are not both in standard form. I want to put them in standard form. All right, so the first thing I'm going to do is rewrite these. So this, okay, I'm just going to flip the 2x and 3y so that we're in the exact form of ax plus by equals c. Now my bottom equation, I'm going to have to flip around, right? I'm going to need to move the 3x and the negative 4y over to the left and the 23 over to the right. When I do that, I need to obey rules of equations, right? So I'm going to subtract 3x and add 4y over. So I will have negative 3x plus 4y equals, and then I would have to subtract the 23 over to this side. All right, so now, if I look at my variables, there isn't a set of variables that would eliminate nicely. So we're going to use that strategy that we just talked about. Okay, let's say we want to eliminate the x's. Okay, I'm going to have to multiply both equations here. So I'm going to take and multiply this top equation by 3. And I'm going to multiply the bottom equation by 2. Now, I didn't make either of these negative because they're already opposite signs. Okay? Since they're already opposite signs, I don't want to change any of the signs. Right? All I want to do is make sure that the coefficients are opposite. So when I distribute this 3 through the parentheses, I will end up with 6x plus 9y equals 63. Then down here we will have negative 6x plus 8y equals negative 46. So now, if I add these equations together, 6x and negative 6x cancel out. 9y plus 8y is 17y. And then 63 plus negative 46 would be 17. Divide both sides by 17 and we get y equals 1. So now I can take this and plug it into either of my original equations. I'll choose the first one. So 3 times 1 plus 2x equals 21. So 3 times 1 is just 3. Subtract the 3 over to the right side. Get 2x equals 18. Divide both sides by 2. We get x equals 9. So my final answer is the coordinate point 9, 1. And again, what that means is if I were to graph both of these lines, they would intersect at the point 9, 1. All right. So you guys try this last one here. Go ahead and set this up for elimination. All right, so it does not matter which variable you choose to eliminate, the x's or the y's. I will go for the y's. Now, if I use the method of multiplying each equation by the opposite coefficient, I would multiply the top one by 4 and the bottom one by 2. However, I can recognize that if I just multiply the top equation by 2, I can get the y's to cancel out. Okay, it's a foolproof method. Okay, to just take the opposite coefficients. That'll work every single time, but you may end up with large numbers. Okay, so here I can recognize, well, I just need to multiply the top equation by 2. So when I do that, I'll get 6x plus 4y equals 6. Then the bottom equation, I don't need to change at all. So this will stay 9x minus 4y equals 4. So add these together, we get 15x, those cancel, equals 10. Divide by 15, and we'll get x equals 10 over 15, which would reduce to 2/3. So I want to take my answer of 2/3 and plug it back into either of these equations for x. I'll use the first one. So we'll have 3 times 2/3 plus 2y equals 3. 3 times 2/3 would be 6/3, or just 2. Subtract the 2 over, we'll get 2y equals 1. Divide by 2, and we get y equals 1/2. So that means these two lines would intersect at the point 2/3, 1/2. All right, so graphing these two lines, it may be difficult to actually tell that this is the point of intersection, right? So solving using this method is probably the best way to accurately find an answer like this. Now, our last example here is a word problem. We want to write a system of equations to represent the data given and then solve and answer the question. So it says, last year, Mrs. Rogers invested $40,000. Part of it was invested at a 6% interest rate per year, and the rest was invested in a riskier venture that was supposed to get us 10% return per year. Combined income for the year totaled $3,120. How much did she invest at each rate? Okay, so this is saying she made $3,120 on top of the $40,000 that she invested. So let's first just assign some variables. Okay, I usually just like to use x and y. So we can say x, y are equal to, so the two different things we're talking about are, well, some of the money was invested at 6% interest rate, and then some of it was invested at 10% interest rate. So what we can say is x is equal to the amount of money invested at 6%, and we'll say y is the amount of money invested at 10%. So we know that the total money she invested was 40,000. So if we just say, well, if X is the money she invested at 6% and Y is the money invested at 10%, one of my equations can just be, well, those two things added together are going to have to equal 40,000. Now, I also know that the total income was 3,120. So what we can think about is, well, the money invested at 6% interest, right? Well, if I multiply that amount of money times 0.06, so 0.06x, and then the same thing for the y, right? I'm taking the amount of money that I invested at 10%, okay, and multiplying that by 10%. If I add those two things together, I should get the amount of money that we made, 3,120. So here is my system of equations. All right? Now, we can solve this however we want. We could solve this by elimination or substitution. When we've got ugly coefficients like 0.06 and 0.10, elimination might be kind of weird, so I'm going to use substitution. It doesn't matter which one I solve for here, so I'll just say y equals 40,000 minus x. Okay, I just solved this equation for y by subtracting x over. So now I can take this and plug it in place of y down here. Okay, so that'll become 0.06x plus 0.1 times 40,000 minus x. That's going to equal 3,120. So I'm going to distribute this 0.1 through. So I'll have 0.06x plus 0.1 times 40,000. So 10% of 40,000 would be 4,000 minus 0.1x equals 3,120. So I can combine my like terms here. I've got 0.06x minus 0.1x. That's actually going to be negative 0.04x plus 4,000 equals 3,120. Subtract the 4,000 over. We'll have negative 0.04x equals, what will that be? Negative 880. Then divide both sides by negative 0.04. So that'll come out to be 22,000. Okay. If I divide negative 880 by negative 0.04. So what this means, okay, is she invested $22,000 at 6% interest. So to find our other answer, I'm going to take 22,000 and plug it in for x. Okay, obviously the first equation is going to be easier to do that. Okay, we could actually plug it into this one. Right? We could say y equals 40,000 minus 22,000. So y equals 18,000. Now for story problems, right, writing this as an ordered pair doesn't really make sense. What we want to do is write out a little sentence explaining the answer. So what I'm going to say is 22,000 was invested at 10% and 18,000 was invested. Wait, did I say that right? No, I didn't. Sorry. we said X was the money invested at 6%. So 22,000 was invested at 6%. 18,000 was invested at 10%. There we go. Okay, so we want to write out our answer to a story problem like that. Okay, so the homework is on the bottom of your note sheet. We will have all of class tomorrow to work on that.